The next factoring type is factoring a three-term polynomial or a trinomial. And there will be two types considered. It'll be either of one variable or of two variables. That is, two kinds are studied. One variable and two variables. But within this factoring type, we have two kinds of problems. In A, where the leading coefficient is 1, and the second type where the leading coefficient is different from 1. We will look at A first. Where leading coefficients are 1, we have 1x squared minus 5x plus 6. We have, these are examples, 1x squared minus 5xy plus 6y squared. Now here is an example where you have two variables, but leading coefficient is 1. Another example, a squared plus a minus 2. And the example, a squared plus ab minus 2b squared. Where the leading coefficient is different from 1, examples are 2x squared plus x minus 15 and 2x squared plus xy minus 15y squared. Notice that this example is a trinomial of two variables. Another example, we have 8a squared. Notice the leading coefficient is different from 1. We'll have to study this for 1. Minus 6a minus 9. And the last example, 8a squared minus 6ab minus 9b squared. Study these examples. There's a type A where the leading coefficient is 1, and there's a type B within the group where the leading coefficient is different from 1. We'll continue with type A. Several properties regarding trinomials that are factorable should be known. A trinomial that is factorable comes from multiplying two binomials. Consequently, when you have x squared in a trinomial, this must come from two binomials which are constructed as follows. Recall my example, x squared minus 5x plus 6. It has to be that If this is a trinomial and it comes from multiplying two binomials, that the factors are going to look like what you see on the right. This is the trinomial. Here are two binomials. Now it stands to reason, in order to get x squared here, and you're multiplying two binomials, this must be an x and this must be an x, because x times x produces the x squared. All that is necessary then, having made this observation, is to determine the two terms missing in the binomials. What number goes there and there that will produce this trinomial? Remember this, find two numbers which, when multiplied, the result is the third term in the trinomial and which also must add to give the middle term. Number. So there are two conditions that have to be met in determining the proper factors. You must find these two numbers which, when multiplied, result in the third term. What are the possibilities? Well, 2 times 3 is 6. 1 times 6 is 6. Those are possibilities. But the same two numbers must add to give the middle term. Well, it appears for the two numbers to add to give minus 5, it has to be minus 3 and minus 2. And that's how you factor trinomials with leading coefficient equal to 1. Memorize this rule. In the next example, you'll notice that it is quite similar, except that it has two variables instead of one. The procedure is essentially the same as the one I have just shown you. In order to get x squared, you have to have x times x in the answer. Now, the numbers in the rest of the trinomial are the same as you see up there, -5 plus 6. It's obvious then that the answer must have minus 3 and minus 2 in it. But because of y squared here, it must be minus 3y and minus 2y to get 6y squared. By the way, the order in which these factors are written makes no difference in the final solution. Let's do the remaining two examples which I gave you earlier. A squared plus a minus 2. We know that'll be x times x in our two binomials. Find two numbers which, when multiplied, give minus 2 and add to give plus 1, the middle term number. How about plus 2 minus 1? Plus 2 minus 1 multiply to give minus 2, and they add to give plus 1, the number in front of A. The example that's similar to this one but has a second letter a squared plus ab minus 2b squared must be equal to, sorry, this should have been a and a. Change that. The last example must be a plus 2b followed by a minus 1b, or simply a minus b. In type B,